Hello, GED students. It's GED question of the daytime, and I am finally done with the concept of parallel lines. Yay! That's the good news. Bad news is we're going to talk about perpendicular lines now. So let's take a look. It says, which two lines pictured on the graph below are most likely perpendicular? So that's just a vocab word you have to know for the GED. If I'm talking about perpendicular, I'm talking about two lines that cross at right angles. So they cross at perfect right angles. Now you might be saying, Kate, what is a right angle? So let's talk about that. Mathematicians often mark right angles with those little those little square boxes, meaning that they're a perfect 90-degree angle. A right angle is 90 degrees. Way I always explain this to my classes is to think about construction. You want the angles in your house for the most part to be 90-degree angles. Like, for example, your floor to your wall is a 90-degree angle, hopefully. If not, your walls are slanted and you're probably one teed-off homeowner, and you might be calling the construction company and complaining that they did a shoddy job. We want that beautiful, perfect right angle between our walls and our floors. We want our walls to stand up straight. And, my other joke, of course, is the IKEA bookshelves. I'm not allowed to build them because I can't get those perfect perpendicular lines. I can't get those nice right angles. And so my husband has to build them instead because my bookshelves always slant. That's not good. That's not how you want your bookshelf. So anyway, right angles, those perfect kind of corner angles like we think of in good construction jobs or in good corners. So that being said, though, when you look at this graph, it might be hard to visualize which ones are perpendicular. A lot of these lines cross, but which ones cross at a perfect right angle? Okay, so I don't even know how to explain it except to visualize it. I'm almost regretting that I made a video here. I think I can see the perfect right angle is right here. And one of the things that helps me see that is that this side, this side, this side, and this side are all about the same angle, meaning like I've taken a circle and I've broken it, and I've broken it into like 4 equal angles. And all the way around a circle would be 360, so that's 90, 90, 90, 90. Whereas I think you can see here that, like, if you look at this one, it's a way smaller angle than that one. That one's way more wide open. That can't be the perpendicular angle. Same here. This little bit is small, and then that's big and wide and open. That can't be the perpendicular angle. This one's a little closer, but still I can see this one visually is smaller than that one. That can't be the perpendicular angle. So obviously these two lines here are the only ones that cross at 90-degree angles. Now I'm going to erase it a little bit. Another way you could test it, so you're mad at me, you don't like it, you could take your little edge of your piece of paper. A piece of paper is a perfect rectangle. It has beautiful 90-degree angles. If you are struggling to see it, sometimes I struggle to see things in geometry, used to get mad at my geometry teacher, fit the little corner of your paper right into that angle and see how it fits perfectly at that nice right 90-degree angle. And that would be a really quick perpendicular check. Okay, so the green and the blue lines are perpendicular. Now some of my students were having trouble seeing what colors they were. They were complaining that I didn't account for people who might be colorblind, so I'll just label that as line 1 and line 2. The blue line and the green line are perpendicular. All right, if you have any questions about this or any other GED topic, be sure to drop it in the comments and I'll do my best to answer it.